let's look at this question. A force B is applied to a bent rod which is supported by a ruler and a pin and a bracket. For each of the three cases shown, determine the internal forces at point G. This point G, remember AA, and there is a force B, and A, J, B, C, D. And this one is, there's a force here, ruler, a hinge, and look at this ruler with a 3 and 4th, another ruler with a 3 and 4th here, slopes. So this is the dimensions, 2 reactions and 1 reaction here, AA, and you need to know the internal force, J. Okay, let's apply the moment equilibrium at point D. By doing the moment at point D, you could cancel out these 2 reactions. You could find RA as a function of B. So summation of moment at point D, summation of moment at D is equal to 0. So RA is equal to B over 2 by applying the equation. Now we'll draw a free body diagram around AJ. Remember that there is, it looked like that. A, we found RA as a function of B, so A to J and caret. So if you cut this member, it will be like that. RA is RA, which is a function of B, we found that, and this is the distance A. And at J you will have 1 moment, okay, and you'll have 1 shear, vertical shear, and one force, vertical, and moment. These are the internal forces and moment around or about point J. Okay, so we apply the force equilibrium, summation force at X for that one, since we have only, you can see that there is 1 in the x-axis and the V is in the x, the vertical force is in the x-axis, so you have 2 forces. So if we apply, we know RA because we found it before. RA is a function of is equal to B over 2, so we could do it. Let's go down. Summation force of X summation forces of X. What is it? Let's see. Summation force of Y. So we could find summation of forces at X equal to 0 because RA is equal V, and of course opposite in direction, because we found RA before. So summation force of X equal to 0, V minus RA, because they have to be in different direction. So V is equal, the shear at point J is equal B over 2. And of course, therefore, the magnitude of the shear force acting at point J is it's B over 2. So then we should find summation of forces at Y equal to 0. If you look at here, there is nothing in the Y, which means that this force is equal to 0 because there is nothing in the Y except this force. So F is equal to 0 so F is equal to 0. So therefore the axial force acting at point J is 0. Now remember, the things vertical, we call it axial, and the things to the x-axis is called shear. So these are the internal forces at point J. So let's find moment at J to find out the moment. So if you want to find the moment here, so we found V, we found F, let's find this moment. How could you find this moment? By taking moment at this point. By taking moment at this point, this is cancelled, and RA is going to be negative times A, and then this moment has to be taken into consideration. So summation moment at J equal to 0, moment minus RA times A, so you can find out the moment. So summation moment at J equal to 0, moment minus RA times A, and RA we know it is B over 2 times A equal to 0, so moment at the joint or at that place J is equal P, the force P times A over 2. So the bending moment at point J is BA over 2. So now let's do a free body diagram of the road. So you have P, you have RDX, RDY, and you have RA, and you have RA. Of course, there is this road. Let's see the 3, 4. So you have the 3, 4, and 5. Okay, so it's here. Okay, so you do it like that. 3, 4, and 5, because 3 square plus 4 square all in the square root. You could find out the angles. And that's what's going to give you here. It's going to give you 4. In the x-axis 4 over 5 RA. And this is here 3 over 5 RA. And then from this one, you could find moment at D and do the same approach. Do the same summation moment at D at this point. So you have everything RA as a function of B. So you could do the same thing. Summation moment equal to 0, so RA is a function of B, so RA is equal to 5B over 2, and then you could take the point, the internal joint G, so it is okay, so the shear, the axial force, and then the moment, and the here A, and then you could find RA and RA, and you could do the same approach, summation of forces at the X, summation of forces at the Y, and then summation moment at J to find the moment. We could apply the same thing, and then we could do it, summation force at the X, the shear is equal to P, this is the shear force, and summation force at the Y, you could find the force F, which is the tensile or the axial force, 3 over 2P, which is the tensile pulling, and then summation moment at J, moment is equal to BA, and that's the acting moment. And we could do the same thing for the last one. It's, remember the things was, the angles was here, this side. So we could apply the same method, 3, 4, and 5. And we could take moment at D to find out RA as a function of the other one. Okay, summation moment at D equal to 0, RA is equal to 5B over 14. And then you could go to the joint J, we know RA as a function of B. We could do the same thing, summation force of X, find the shear, summation force of the Y, find the axial force, and summation moment at J to find the moment. You could do the same thing for the acting point axial force, and summation moment to find out the rest. Thank you very much.